Good morning, everyone. Nice to see you again at Connect University for this one, the first Publican for the year 2025. I think it's fitted. I'm Alex. I'm coordinating the project. I'm just here simply to warm things up. I'm saying this fits as a first session because we do live, let's say, uncertain times. So any help that we can get in seeing what we can slightly predict or even try and plan for what could be coming in this year, this is exactly the session for that. We will plan on seeing not only where should European computing research go over the next 10 years, but we will also go through the related things which might affect the entire digital ecosystem. For you, the viewers, if you do not have the time to watch the session until the end, we will put the recording on the Digital EU channel. I will leave links in the chat. The same goes for the slides. And speaking for chat, remember that's exactly the place where you should put your questions in. So please do that, and we'll make sure that they make their way towards the speakers. So without further ado, I will leave Rolf Riemenschneider, our head of sector for Internet of Things, to kick things off and also present the speakers and the context. Thank you.
Thanks so much, Alex, and good morning, everyone. I'm very happy to be here, and particularly happy to be here with Corinne de Busquets and Marc Duranton, both, one of the leading persons in the HiPEAC project. So, to give an introduction, it's an honor because the HiPEAC 2025 conference constituted a 20 years anniversary of the network. And I think that's a bit we could be proud of that. So since 2004, when it was founded and I was part of the unit, we had the idea of network of excellence. It was a foundation to think about, to create a think tank on computing. So we couldn't predict what is all coming along, but it was an idea to see, to set a vision to complement research vision on computing with a shorter term vision on industrial research. So since then, the first year was 2 years. Now we have an annual vision roadmap. And that's really needed because you see the pace of innovation that we benefit from yearly update of the HiPEAC vision, I think. And now you see the title, from the last 20 years, now we want to predict the next 10 years, which is quite ambitious given the dynamics in the market. As said, the success is reflected in related activities related to high-performance computing. So you made it as a success to host high-performance computing centers, which again, covers 30% of the top 10 computing resources, supercomputers we have in the world. At the same time, you covered industrial needs, meaning that we go from high-performance computing to industrial computing, embedded computing, real-time, and dependent computing, cyber-physical systems, you name it, where we influence work in key vertical domains like aerospace, energy, health, automotive in particular, and others who are inspired by your vision. So in 2023, you came up with the idea of races, and I think, it was quite 2 years back, but still, the races accompany us in our daily lives. So I want to pick a few of them in order to bring you, to that attention, why that's still important. So the first one was on the continuum, on a convergence between the high-performance exascale computing, the cloud computing you all know from the data center, and embedded computing, or computing you have on your smartphone. So I think there's a real, change in paradigms as well as in performance you have seen there. So this convergent computing continuum constitute also, the baseline for our Horizon Europe new endeavor, a new paradigm for edge computing. The more than 350 million euro have been spent on research innovation projects under Horizon Europe, Destination 3, and under that scheme from cloud to edge to IoT, and is still continuing. So nowadays we talk about converging of fixed and mobile, telecom, cloud, edge, IoT. So I think, we go for the next challenge. And there are more industrial communities or stakeholders, domains which are influenced by that vision. It will not stop at one place. And we see that also in the different domains. Automotive is under pressure today to design the new EE architecture of the car. Other sectors like energy will follow soon. And then it's a paradigm, part of a digitalization strategy which you cannot stop. The convergence between telco, cloud, edge, IoT is covered by what we call, you may heard about it, the 3C strategy, collaborative communication and cloud computing strategy. It's built in the new work program 2025 and 2026 of Horizon Europe under Cluster 4. So more to come over there. So first race was on convergence, computing continuum. Second is artificial intelligence, and you are all aware of it. It's influenced our daily discussions. It's on the top of the agenda of many of the decision makers. And in 2010, you said, well, computing has to be made simple for the humans. Nowadays, if you have tools like Gen AI, generative AI, it becomes more simple. You have tools, to facilitate programming, to do programming and software engineering in a fraction of time. And traditional companies like automotive manufacturers, without having the specialists in software, they start programming and doing their own applications. So that's really changing again the ecosystems. Beyond that, talking about Gen AI, you all know ChatGPT. Some of you already use it regularly. You see the performance and the deep rise, in expectations on this new technology. But of course, AI is also closely linked to energy consumption. That keeps us busy as well, thinking, how to cover, where do we get the energy from, how to deal with the peak loads of these data centers, which are newly built, which are popping up like mushrooms, not to lose track in Europe. So how to facilitate the permissions where energy first and then permission to build data centers. So where do we get the energy from? Again, I want to recall some of your paradigms. You say, well, data centers could have different computing paradigms, like opportunistic computing. At that time, I think we called it free lunch computing. So do the computing, do the workload when there is free energy, there's renewable energy, and where is low-cost energy. So that's, again, changing the workflow, be flexible in terms of energy usage, would facilitate the permissions. And it's also a discussion, we have our colleagues from DG Energy, how to integrate data centers into the grid system and have benefit from the flexibility and the heat generated on the other side. You heard about a new generative AI or LLM, large language model, which is called DeepSeek, revolutionizing, all what we talk about, at the moment, shook up also the shareholder market. Why that? All of a sudden you have an LLM which is capable of doing similar things at less cost, at less energy, and less fraction of time. So which shows us we're not the end of computing. So what the Americans did with ChatGPT is not the end of the line. There are other computing paradigms you could improve, you could do more. It's particularly needed for industry who have to use these new capabilities of LLMs in their industrial applications, but they have to scale it down. They cannot afford, the big data centers. Paradigms like frugal AI, I think in France is quite prominent, and exactly wants to do that, package LLM for the industrial use, scale it down at less energy, be more efficient, and be integrated in the different domains, and that could be eventually a new endeavor for us, for your vision, how to make industry more competitive and make them capable of integrating the new technologies. So there are new opportunities coming from European companies. Today, there are figures that less than 13% of the companies are using AI. And that's not talking about LLMs or Gen AI, it's just the basic AI. I think there's still, a huge gap, and Europe has to close the gap on that one. I don't want to expand more on that one, but there may be a few updates what we do at the moment. As stated by Commissioner Virkkunen in a mission letter, we definitely have to run and jump on the next wave of frontier technologies, including supercomputing, semiconductors, IoT, genomics, quantum computing, and you name it. And lately, we have to make sure that industry is capable of using effectively and integrating and exploiting these technology innovation. This week, the competitiveness compass has been published with 3 pillars. And one key pillar is closing the innovation gap with China and US. So central to that one is an AI strategy, investment into infrastructure like AI factories, AI in science, and in particular also apply AI for industry in different domains. So apply AI in manufacturing, in energy, in healthcare, in farming, and you name it. And finally, also the EU quantum strategy. So then also we proposed a Cloud AI Development Act within the 100 days, which is about to come, to have a discussion on sovereign computing. So industry needs to have sovereign infrastructure to train the models, to make sure the data is safe and secure, and that we have trusted training and trusted data centers in Europe. So it's an investment again in infrastructure. So all that is to come. I think it's on our table. And then from that point of view, the vision of HiPEAC is very, very relevant. In particular, know what we can expect and what is to come in the future. So with that, I thought, I was need to set the scene, to raise your expectations, and I'm happy to pass the floor to Koen as a coordinator of HiPEAC before we could dive into the future vision in the next 10 years. Thank you so much, and wish you a fruitful, stimulating, exciting seminar. Thank you.
Thank you, Rolf, for the nice introduction. Yes, I'm Koen de Bossche. I'm the coordinator of HiPEAC for several years now. So HiPEAC stands for High Performance Edge and Cloud Computing. And we are actually focusing on the system level. Here you see in the European Processor Initiative, you see Accelerator, the tools to design systems. Of course, we are also aware of everything that goes on in technology, but this is not our primary focus. Of course, we look at what's going on there to see how it will impact the system level. And the same for the application domain. We are aware what's going on there, but this is not our core topic in HiPEAC. We are a CSA, Coordination and Support Action, but at the same time also a European network. We count at this moment almost 800 senior members in Europe, and they bring in their colleagues and students. That's another almost 1,600 affiliate researchers from 500 institutions and from 49 countries, which means that we go beyond Europe a little bit. But of course, our core membership is in the European Union and also UK, Norway, Switzerland, and so on. Membership is free of charge. Everybody is welcome in our network. This is a CSA, so we have work packages, including tasks, and I would like to introduce a few. So we have the HiPEAC Vision, of course, that will be presented, but I would now like to focus on the conference and the competence building. We have a yearly conference. It took place last week in Barcelona. It was the 20th one, and it was attended by 800 people, which makes it the second largest conference in Europe in systems. We also have companies joining us there. We have booths. So this is a real, very important networking activity with around 40 workshops going on in parallel during 3 days. We also have a training event, and our main training event is the HiPEAC Summer School called Agassiz, where we have 20 courses running during 1 week, and people can just compile their own program. And there are also a number of projects that sometimes use the summer school to also include their own training activities. Like last year, we got Discover Us, which is another CSA who got the training, and they inserted 4 courses in this container summer school, I would say, that can host them. This is a picture. The summer school is attended by about 200 people, senior and junior people. And this is for many people a life-changing event in the sense that they meet other researchers in their own domain, especially the PhD students with whom they can continue their career for the rest of their life in some cases. The last one is the jobs website, which we started several years ago around, well, in the very beginning, but it really started flying in 2016. So on average, we have something like 600 open positions per year. That means 3 per working day. After COVID, there was a surge, and we came back to normal in 2023. But as you can see here, the job market is cooling down a little bit. So last year we got fewer vacancies than the previous years. But this is a tool which it's only European open positions, but it's open for the whole world to see the information. So we want to attract talent to Europe, and we also want to make sure that talent in Europe can move freely to the place where they can have the best job opportunities. So that's for the HiPEAC network. And now I would like to give the word to Marc for the vision.
Thank you, Koen. So I'm Marc Duranton, and I will introduce you the HiPEAC Vision, and more specifically, the last one, HiPEAC Vision 2025. So the HiPEAC Vision is a deliverable of HiPEAC, and basically our aim is to show the trans technology evolution and the position of Europe in the domain of computing. So this is the 11th iteration, and you could download it at this link. So what is the overview of the HiPEAC Vision? So it's a vision. So of course, it's very difficult to predict the future. So we might be wrong, but the past years show that sometimes we were right in the direction. So it's a mid and long-term scope. So there is a definitive continuity between the previous HiPEAC Vision, and we will see that the races are one example here. But of course, the world is evolving, and the vision are influenced by the evolution of the various domains. So for example, artificial intelligence, and also the impact of the economy and political evolution in the world. So also some focus shifted because some action were already ongoing from the previous recommendation. And then the HiPEAC Vision is a community work. So everybody is welcome to help us and to contribute. So this presentation will mainly explain why we end up with the recommendation, and you could download and read all the detailed recommendation in this document. So just go back to what Rolf was saying and about the races that we identify in HiPEAC Vision 2023. So this was the general theme of that vision, because we are in a race against time, because of course of external constraint like the global warming, but also because of the evolution of technology. And nobody could deny that artificial intelligence is evolving at ultra rapid pace. But also we are in a race against the rest of the world on multiple aspects, on economy, reducing dependencies from the other, ethics, and so on. So at that time, we identify several races. As Rolf said, what will be the next evolution of the computing infrastructure? At that time, we called it next web. So now we call it the next computing paradigm. But also, of course, about artificial intelligence. And we see that is really now a race, at least between US and China. And also for new hardware, for cybersecurity, for sovereignty, not only from the technological point of view, but also on the data, in the content, and on product. And of course, race for sustainability linked to the global warming and the global evolution of the planet. So typically in 2023, we had this kind of vision where everybody started from the same position. And of course, we are hoping that Europe is really in the right position. But what we could see, and perhaps from the Draghi report and from the other, is at least in some domain, will not be leading in some parts. So this is also why we try to define what we could do as Europe to be, let's say, back or more important position in this race. So indeed, what we see in 2025 is that the races really identify global warming, we see the weather and the climate condition, artificial intelligence is really an exponential growth. You see the economic and the world political is also changing. So really this year we see really an impact on artificial intelligence on race for sovereignty. What we also said in the past, and we continue to recommend, is that we need to have holistic approach and we need to break the silos. It's by combining all our knowledge in Europe that could be back in the race. So this is one of the themes that we called next computing paradigm. So in fact, we call it this because we didn't find a better name, but if some of you have a better name, please let us know. So that's why our HiPEAC Vision 2025 focus is how to enable this next computing paradigm. But first, what is this next computing paradigm? Well, in fact, it's a kind of a patchwork, a puzzle, a jigsaw of various elements. Of course, the root is what will be the next IT infrastructure, so the cyberspace, how it will evolve. So that is the core of the next computing paradigm, but also with this impact onto the real world, what we call cyber physical systems, so the interaction of the IT with the real world. And for this, we need also the help of hardware, accelerator, computing system. But also we need to be very efficient. So for that, we need to use tools that could help us to increase our productivity. But also, of course, there are also attacks, cyber attacks. So we need to have a very deep support from safety, cybersecurity. But we need also to be compliant with sustainability. So that's a clear element. So all these elements, of course, with the glue of artificial intelligence, could be a way to go into this next computing paradigm. And this is, of course, something that we need to focus on Europe. So to be more clear, so what is our vision is that today or in the past, a program, a computer application was a software that you compile or that you download on your laptop and you execute in your laptop. So we see the evolution of anything as a service, and we put this to an extreme where tomorrow computing will be a dynamic collection of services that could be dynamically glued together to solve what you are asking on what you need. This is basically the core of the next computing paradigm. This is really thing that services are anything from software, but also from hardware. So computing memory will be also services that will be offered to solve the problems. And of course, to glue all these services together, we need an orchestrator. So this is the core, is this orchestrating system that is an intelligent system that understands your will, what you want to be done, and will analyze and see what are the services that could be done for doing that. So if you break it down into pieces, so indeed everything is seen as services, so anything as a service. So all these services are selected and orchestrated. So the orchestration is of course quite complex, but we could break it into several parts. So the first one is decompose the application into basic services. Let's say I want to go to Brussels to make this presentation. So what need I do? I'm living in Paris, so I need to organize my trip to Brussels. I need to see how to go from my home to the station in Paris, then to the station to the EU building, then how to enter. So This decomposition is a part of the orchestration. So then after, you need to see what are the services. So for example, how can I go from Paris to Brussels? I can fly, I can take a train. So again, here, I need to discover and to select what is services. So then now you need to select the services, not only about the functionality, so that's going from Paris to Brussels, but also with non-functional requirement. Let's say, well, I want to have the lowest CO2 emission. So then that drives me to use the train. That is also in terms of location to location faster than going to a plane because it's a short flight, you need to be long time before and things like that. So all these non-functional criteria are also key to select the right services. So of course, after I need to select the services and I need to agree on to buy their services. So buying the train tickets, having all the operation to register to the EU building and things like that. So of course, there are some payment or some rewards. So here, for going to Brussels, indeed, I have to pay my ticket. But for example, if it's services, virtual services, I could also get it in exchange of offering some of the compute power of my smartphone, for example, because my smartphone during the night, it's plugging, but it's not computing. And, and it has a potential of being used for other tasks. So that could be a way to buy some credit for some services. So you could see this way from the technical side is really having this idea of distribution of computing, but also from the business point of view, this could be also be interesting and open new business opportunities. And of course, all this need to involve a lot of technologies working together. So I was talking about this non-functional property. These are very important because now most of the protocol and way to activate action are mainly done on the functional part, what you want the system to do, but not into these non-functional properties like latency, performance, locality, and things like that. And you will see that if you want this to be applicable not only on the cyberspace, but also on the physical space in the real world, this non-functional property is important. For example, latency. If I have a self-driving car, I want it to be safe in the sense that it should be able to detect a pedestrian very rapidly. So for that, I need to select a service that runs locally on my self-driving car, and perhaps not a service that might be 1% more performing, but with a long latency because, yeah, it's processed on the cloud on the other side of the world. So this is, again, why a non-functional property is very important. And you know that, for example, latency is not part of the current cyberspace, or very rarely. We don't care about latency when we are making a programming or using applications. So, of course, if the response time of the website is 1 second, it's quite boring, but it's not killing. And when you want really to have this system extended to the real world, this is a key element. And of course, to guarantee this, we need to have hardware that could enforce this, not only for keeping latency, but also security, isolations of this task. For example, if you execute one service on your own devices, you want this to be really into a secure enclave so that it will not perturb the rest of your system. So really, this is the core. And I was thinking about the independence of the software, so of the services. So it's basically what we start to have here with everything as a service. So application as a service, cloud as a service, HPC as a service. but we also put this to the level of the hardware. So that means that not only data, but also application will migrate. So now mainly all the data are migrating. That's the core of the web, but very few application migrate. So we want also having this flexibility to migrate application. And that means that also hardware, so when you have processing resources and things like that, they should be considered as a resource. This is perhaps not new. You perhaps heard that Elon Musk wants to use the robotaxi as a pool of computing resources when the system is not running. So that's basically this idea. Consider how many smartphones are not in use during the night while recharging. So if you could use all this computing power, then you don't perhaps need to build one more data center, only by reusing what is existing but not in use because of recharging, because you are not using all computing infrastructure 24-hour a day. And this is mapping also a part is part of the global orchestration mechanism. So not only on the service, but also where to make these services, where this is the more efficient here. So how to see this? So also this idea could range from very local to large scope. So you could consider that now when you program using Python, in fact, most of the core, most of the services are done by library calls. So you could see that it's already this idea where Python is the orchestrator, the glue between services provided by library. The next generation of hardware will be using chiplet on interposer. So chiplet could be CPU, they could be dedicated dedicated accelerator, but it's the same idea. The CPU could be the orchestrator of special services like neural network acceleration with NPUs or crypto services that are orchestrated by the CPU. And indeed, this could also extend to sharing resources between devices. So, for example, if my smartphone has not enough compute power to make some AI functionality, it could ask to my laptop or to my PC or to my set-top box. So basically, all my devices could be linked into some kind of super devices that could bring more capabilities. This is not a sci-fi. This is already that you could find into Harmony OS, for example, where, as they say in their document, services can be seamlessly transferred to the most suitable devices. And basically, we could have a capability collaboration on resource sharing amongst our services. So this is from Harmony. So you have an open version, which is Open Harmony, and in Europe, so the Eclipse Foundation is having its own version on Oniro. So this is the root of what we could do. And of course, the sharing of resources could be done at company level, but also at global planets level. We were working also with Destination Earth, where the goal, it's a European program where we want to build a digital twin of Earth for weather forecast and things like that. So for this, we need to aggregate several data centers everywhere on the world to work together. So this is the same idea. So you see this idea of next computing paradigm could apply inside your devices, between devices, and even between data centers. Again, one example, one starting point is what Apple is doing with their Apple Intelligence. You see that when you want to make some AI, so the orchestrator, and this is the official slide from Apple, they also use the term orchestrator, which select which on-device model could solve your request. But if it's not enough, they will offload to off device on the Apple server here some functionality. And again, if it's not enough, they could also call to a ChatGPT. But this is this idea of aggregating devices to make more functionality instead of having a very big devices in the cloud that is doing everything. There is also a side effect that, by the way, is also pushed by Apple, is that you only communicate when it's necessity. So that means that if you don't need to go outside your bubble, outside your device, then you don't exchange data outside. And if you have to exchange, then you need to encrypt in a secure protocol. But that means that you are not always connected to the cloud doing the task. So mainly, it's like onion rings. So you start first to do it locally, and if it's not enough, you go further and further, but only if it's necessary. So why this view could be good for Europe? Because basically, as you see, it's really could empower small and medium enterprises, because all these companies could provide specialized services, and they could use all the other infrastructure without needing to have a very large investment, because most of the communication infrastructure and the computing might be already here. It's also, as I explained, starting from the edge and growing to further away if it's not enough. So, but it's really enforcing edge computing first. It's also promote sustainability. Sorry, because first, it's avoid unnecessary communication. And you know that, for example, in a chip, communicating took order of magnitudes more energy than computing. So avoiding to move data is key to consume less energy. And also for sustainability, well, if my smartphone is not powerful enough, I don't have to put it away and buy a new one, because then it could tap into my laptop or into other resources. So that could side effect to augment the lifetime of the devices. Again, good for the planet. And of course, with this idea, it reduces the reliance to hyperscaler. Of course, some function could only be done by this hyperscaler, but we try first to do it with the local resources. And again, all the services could be diversified. It could be adapted to various countries, to various culture, and things like that. And also, it could cope with the local regulation. So in terms of security and data. So as non-functional requirements, we could say that in Europe, you cannot send data to outside of Europe. If it's part of the non-functional requirement, then automatically you will only use services that are in Europe. So that's easy way to enforce this kind of regulation. And the fact that we communicate only when it's necessary and in encrypted protocol, that sure also ensure security. And of course, as it's open and everybody is able to provide services, it's really encourage innovation and collaboration, contrary to close ecosystem where you can only rely on the services provided by big hyperscaler, or in the domain of AI by company like OpenAI, Microsoft or Google. So really what we see is that we are now mainly in the drive of cloud computing, where everything is in the cloud. Linked to the cyber physical and influence to the world, we see that some functionality need to be done at the edge, like for self-driving car. I told about pedestrian recognition and things like that. This is on the local part, but mainly the main training of VCI are done in the cloud. So we are going back to our vision of the NXP, which is more a distribution and cooperation of a system interacting to each other, to only communicating and exchanging when it's necessary, and also having the computing done where it's the more efficient according to the criteria. So this is the view of the next computing paradigm, but of course it's closely linked with the interaction with the physical world, which in the past we call cyber physical systems. So we see that the web of humans, so what we call the web today, will be more and more having machines that will talk to each other. And machines will interact with the physical world. For example, here you will have self-driving car that will have to understand the world, so the pedestrians, the road, or the vehicle, but that need to communicate between them and also with the city. Why not with the power grid if it's electric car and so on. So that means that real world constraints like safety, real time, and location need also be considered. And again, we could improve the efficiency of the system by digital twins. So how we consider digital twins and why it's important? Because in cyber world, we could do whatever we want. In the real world, it's not the case. There are some variables that we could not play with, like time. We cannot accelerate time. We could not stop time. But if we have a digital twin of a process, we can use the time as a variable. We can forecast that will be in the past, that will be in the future, or see what was in the past. So then we could analyze what are the causes of a problem, or predict what will be the best behavior for a self-driving car. So digital twins, and digital twin could be a service that could help, for example, a self-driving car to be more efficient in driving in the environment. And also, we need also to have what we call 4D computing. So as I just showed you, time is important, but also the localization. So it's clear that, again, I take the example of a self-driving car, that its behavior in Europe, in continental Europe, and in UK need to be different. You don't need to drive on the same side of the road. Same thing, a drone will not have the right to fly over certain parts. So the localization is very important. And even for me, I am entering here in this room, so my laptop has the right to connect because I'm authorized, has the right to connect and to display on the screen in this room, not in the meeting room just behind me. So that means that localization should be part of this next computing paradigm. So again, here, there are already action in this direction, like the spatial web proposal from the IEEE, where, well, it's perhaps very small, but you could see that it's allowed to support object within a dimensional range, spatial, pressure, and things like that. So that means that you will have some kind of a bubble around you, what we call in the HiPEAC the digital envelope, that's allowed to have this idea of 4D, so time and space computing. So again, as some kind of conclusion about this part, you see that it's very important to bring all the communities together. The next computing paradigm is not only about computing, it's also about communication. It's also about security, encryption, how to give reward to services, how to take into account non-functional property like real-time safety and things like that. So in Europe, we are very strong in some of these communities. So, but perhaps what we need is really working together, breaking the silos, working together so that we could bring this NCP. And that means, for example, having an open standard that cover all these aspects. So this is what we recommend in HiPEAC, to really working together to see all the aspects that could bring this next computing paradigm. And I go really slightly on some aspects, but here there are also a lot of business aspects that could be taken into account. Because, for example, if you want to discover services, we need perhaps something like Google. So some way to be able to centralize services to get access to this. You need also some services that say that these services you can trust and things like this. I guarantee that this one is good. So again, we could create a complete business model on various businesses around this system, like the web created a lot of new business. So of course, the HiPEAC vision cannot be here without artificial intelligence. And it's clear that this was really a boom. So just to give you a few points, ChatGPT attracted nearly 500 million visitors in end of 2024. So if we see the growth on the number of visits when it was open in November 2022, it was 152 million visitors. Last year in November, 3.8 billion visitors. So that means that AI is basically the fastest growing services that we have seen in the digital world. Sorry. Also, one thing that we notice is that people say that there is a scaling law also of artificial intelligence. Of course, there is, we need always bigger and more demanding network, but also we could see the opposite. The performance also decrease. The performance increase so that we could decrease the size of the neural networks or the LLM for the same performances. So here it's an example for the performance of the initial ChatGPT in November 2022. So this is one benchmark. Well, I don't enter into detail, but say it's 70. And we see that ChatGPT at that time was using 175 billion parameters, but now model 2 years after, exactly 2 years after, that took only 14 billion parameters, are even better in this field. So people are saying that for equivalent performance, we get a decrease in size of LLM, but by a factor 4 to 10 per year. So 10 is given by the CEO of Anthropic. So meaning that for the performance of the system today, in 1 year, it will be done by a system which is 10 times lighter. So took 10 times less energy or 10 times less compute to do it. And we see even model like Phi4 are even far, far better than the original ChatGPT. And also, we see that open source model, when I say open source, I should say open weight. So meaning that the weight are available, but not the training database, not all the software that were used to train the model. So it's not fully open source, but at least you can use as a network, are really catching up within few months. And I think that you cannot skip the DeepSeek event from last week. But I think which is also very important with the result of this DeepSeek is that we could use this large model. So DeepSeek, as you see, is 671 billion parameter to train a smaller network. So if you take DeepSeek and fine-tune, train a small 14 billion parameter network, you can put this small network really, well, more specialized, but having far better performance than the general purpose ChatGPT or Claude 3.5 Sonnet. So that is what we are saying, is that by having smaller specialized network that could be running locally, a 4 billion parameter could run on my laptop, no problem. So you could have very top performances. So that's the first message that we want to do. Also, what we observed in 2024 is that even on learning, on the first learning that took a lot of data and things like that, we start to know how to do it distributed. So two companies train their network around the world. So it's not so simple because you have a problem of latency, synchronicity. So if you want to do it efficiently, this is really a research topic. But again, here you could see that each data center could be services for training data center, for training your neural network. And you don't need to have a big data center because you could use the resources from various data center. So you see the link with the previous NCP. Then also what was new in 2024 is this idea of test time compute or inference time scaling that was pioneered by O1 and O3 from OpenAI, but also democratized by DeepSeek R1 in OpenWeight. So that means that we have now 3 steps in artificial intelligence where we could use a compute. The first one is the initial training. Excuse me. So the pre-training. So that is basically where people usually say that takes the most of the time. We have also what we call the fine-tuning. So from the foundation model that was trained here with a large amount of data, you will fine-tuning, you will adapt it to be specialized in a particular function, like being a chatbot, like generating code and things like that. But now we have also using computing during the inference. So meaning that the LLM could iterate on its own answer to try to improve it. And this is really a key in terms of performance. So I'm sorry, it's not perhaps visible here, but there was a benchmark that was done to be very hard for LLM. It's ArcAGI stuff. So indeed, GPT-4 only performed 5% of this benchmark by end of 2024. But O3, with this test time compute, goes to 88%. So that means that they have to redesign a new benchmark. And of course, as you see, it's cost a lot in terms of compute power because it's iterating a lot on this system. But that means also that you don't need a large database because it's not training. It's only inferencing, but running on already trained neural networks. So you could also do it at the edge. And it's basically what you could do with the distilled model done by for example, a DeepSeek. So that means that now in terms of compute, it's not training that takes the most energy, but it's inference. So you see, before the test time compute revolution, for example, SemiAnalysis thought that OpenAI need nearly 7 times more GPU for the inference than for training. So, of course, because there are 40 million users, but also because of test time compute. So now the challenge is not near, of course, training and learning is really important, but now the focus is more on inference. So how to improve efficiency at inference level, and it's also one of the breakthrough of DeepSeek. So of course there are development of special hardware. So I think Grok was the initiator of this. But also, you see that big companies like AWS were releasing dedicated chip for inference. They're inference, yeah, but they have also chip tuned for training, trainium. And also in terms of algorithm, we need also approach that don't need to use all the neuron of a large language model. So this was the idea of a mixture of experts, where basically inside this big monolithic LLM, you create experts, so area that are more tuned for a particular function. And when you are in inference, so when you are asking this LLM to solve a particular problem, you only activate part of this specialized idea. So this is again not new. Of course, we don't know the detail because OpenAI is perhaps now more closed AI. So the last model that we are, a lot of information was GPT-3. We don't have official information about GPT-4, but it seems that GPT-4 is already this mixture of experts. So that means that they are using 16 experts within GPT-4, and they only use 2 during inference. So that means that they only need 1/8 of the compute power for inference compared to use of all the system. And of course, this is also one approach of DeepSeek, because in inference, so DeepSeek is 671 billion parameter, but they use only 37 billion parameter, so selected expert during inference. So that means that they use 18 times less compute power than if they were using the complete system. So one other approach, instead of using small part inside the big network, is to have separated, dedicated experts. So it's called Agentic AI. Well, there are different definitions of Agentic AI. I think most of the AI companies are using this term for LLM that could interact with the physical world, like with a browser, with your laptop, with things like that. But also there is this idea where you have agents that are more specialized, and this is this idea. And clearly, agent is a keyword of 2025. So Eric Schmidt, the former CEO of Google, was promoting this. Of course, Mark Zuckerberg, Jensen Huang, the CEO of NVIDIA, and Sam Altman, the CEO of OpenAI. So again, what is the key element of agentic AI is this idea of splitting a request by an agent manager or an orchestrator and dedicated it to more specialized agent. And the idea that we are promoted is that this agent could be distributed. They could run in different devices. And if one device is not powerful enough, it could delegate to other devices. So this is, again, very linked to what we explain with the next computing paradigm. But what is very important is that how this agent will exchange data should be in a commonly understood and open protocol that, of course, not only rely on functional requirement, but also on non-functional, like response time, potential level of hallucination, localization. Yeah, I don't want to use, for example, a server that is in US or in China for my private data, and so on. So it's very important that the community works together to commonly define this exchange protocol that should be open to allow a broad acceptance. Otherwise, we will have the OpenAI, Microsoft, and things like that, that will create their own closed ecosystem, and that will stop other companies like European one, like research, to be able to do that. And really our idea is like TCP/IP was a way to allow various operating systems to communicate with each other. That basically gives the start of the web. We want to promote and to put this kind of protocol that allow OS in this kind is not anymore operating system, but orchestration system to exchange AI-related information. And I think that you clearly see the links with what we told previously about the NCP. So we want to use this agentic AI as a blueprint to develop the NCP technology. So this is a small example where we have agent orchestrated together and having the clear protocol that will be open, standard, so that everybody could contribute. And here, this will allow to have closed ecosystem, and here Europe could be back into the game. So next important thing to support this is indeed we need to have a new hardware. And I think it's clear that hardware is a drive for artificial intelligence. The first revolution of artificial intelligence was in 22 with AlexNet that reduced the error in image recognition. And basically that was done with 61 million, not billion, million parameters, so very teeny networks, but that still use 262 petaflop that was done in a graphic card to do it. And now you see that GPT-3 was required 323 zetaflop, so 1 million more a floating point operation. So because of the hardware, we're able to code this, that's allowed to drive this system. And not only because the hardware was able to do it, but was able to do it at an affordable cost in terms of energy. We see that, well, of course, the transformer paper was not present in 2016 because it was done in 2017. But even if the theoretical paper was done before, it will not be practicable in 2016 to make GPT-3. The cost in energy would have been too high. And we see a correlation between the generation of GPT and the efficiency of computing. So cost of energy is really a limiting factor. And we see here also data from NVIDIA that in AI, we have 1,000 time acceleration in compute in 8 years. And it's not due to Moore's law. Moore's law has only a small contribution, but force between due to data coding, we go from floating point 16 to floating point 4, but this is only a one shot. We, of course, now we could go to 1.51 bit coding, but we cannot go really further. But also with the progress in architecture. So this is the message. We need to work on very efficient architecture. So we have data centers that consume between 5 to 10 gigawatts, but also you see that we could also run AI locally. So this is a project Digit from NVIDIA that could allow to run your 1 billion parameter model locally. You could run all this small model up to, well, depending on the memory, up to 24 or 30 billion parameter into your laptop computer for tens of watts. Your iPhone is able to run locally model for a few watts. There are boxes, IoT boxes that could run small LLM for 1 or 2 watts. And there are research, so this is one chip that we develop in CA that could make image recognition for a few milliwatts. So here, this is really a challenge with this local AI for inference. As you see, it's more and more important. We need to work on new architecture that are really efficient here. And the last but not least point, we could also go back and see some kind of different trends. Until now, the computer were basically done to make reproducible result on precise computation. But we see now that with this new generation of computing system, like LLM, use approximate computation. So, of course, with very low precision, but LLM could also hallucinate, so it's not exact. They are using random number to select a certain output. There are also other ways, like Ising-based accelerators that are exploring an energy space to find what could be the best solution. There are Monte Carlo Bayesian approach, and even quantum computing could be seen as approximate because it's a stochastic measurement of the result. So we are going from Turing machine. So Turing machine say any form of mathematical reasoning can be made by a machine, to neural network approximator. So the basic theorem from neural networks was done in 1943 by McCulloch and Pitts that say that a finite size neural network can approximate any function to a desired degree of precision. So we go from precise calculation to more approximation, more and more with a different approach. So of course we need to combine the two, and it's why we perhaps need to think beyond purely digital, classical Turing-like hardware to do that. And of course, to support our productivity, we need tools. I will not spend time into software. So just this was an example. I asked O1 to generate code for a game of the 19s, like Asteroid, Game of Life, or a Flappy Bird. So it was able to generate code with few iterations. I didn't look at the code at all. When there is an error, and cut and paste to the chat page. So now this AI tool are able to generate code from 150 to 1.5K line. Next year, I think that they will improve. So that's clear. That code could be more and more generated by this AI. But of course, we need a little bit supervision and check that the results are correct. Otherwise, we could end up to very strange results. We could even, so some company, for example, in Japan, propose AI scientists. So artificial intelligence that were generating ideas, checking that they are new using semantic scholar. If they are new, trying to make an experiment, make the experiment, get the data plot, generate a manuscript, and even review the paper. So today the quality is very poor, but again, this could improve. And of course, perhaps in the future, the scientific research could be changed a little bit. But we see also that in the domain of chip design, artificial intelligence is also helping here. So Google have this alpha chip that help making a good system. And this is really an important point. And well, there are some experiments of using LLM to generate hardware. Today, the result automatic when there is nobody in the loop are not so good. We still need human supervision, but when it's human supervision, this is more like an amplifier. So, yes, so I'm finishing. I am finishing here. So the key elements also for the element are cybersecurity, and this is really important, and we need to take cybersecurity into account. Because of this interconnection, we need to ensure that we could analyze the code of the agent. So cybersecurity is a key element for the system. And we need also here support and use artificial intelligence to analyze the attacks, to mitigate the trade. And of course, one of the major challenge is to be sure that this LLM will be aligned for our need. And yes, with AI, it's always a battle between the sword and the shelter. So now I give the floor to Koen for sustainability and the position of Europe.
Thank you, Mark. These are two short items. Let me, yeah. So the first one is sustainability, and we only have a couple of recommendations here. First of all, there's a digital product passport that is used to indicate what the sustainability properties of a device or a service is. We believe that this should be implemented. Finally, the technology is there, because we will need it in a number of applications, like the orchestrator. If the orchestrator wants to use a service, and there are several options, for instance, for storage, it would be interesting that the orchestrator can know what the emissions are caused by a particular service, and then pick the one that has the best performance, for instance, either performance-wise or emission-wise. So that's one. And also for consumers, if you buy a device, very few people are aware what the emissions caused by the production of the device is. We call it the embodied emissions. Like for a smartphone of 300 grams, it could be 50 kilograms of CO2. So if you have this information in the shop, you can also base your own decisions on that information. Of course, if we design systems, we could also plug in these models into our design tools, so that we can make trade-offs between, well, if we add more caches or more memory, what is the impact? The system will be faster, but it might also have a higher impact on the emissions. So the fact that we have this means that we can play with it and make our decisions based on the information that follows from that. A result of that is, of course, that if we design systems that are more sustainable, we might sell less because they might last longer, and this will impact the business model of our companies. So all companies are familiar with the business model canvas, but there is also another one, which is called the environmental lifecycle business model canvas, in which companies can find out what happens with the end of life, for instance, of a company, of a product, the environmental impact, the environmental benefits. Sometimes a device will help the Green Deal, for instance. So these are models that can be used by companies to become more environmentally aware and to make the right decisions. So that's for sustainability. And then there is a last one. We also looked at the strong and the weaknesses of Europe and the opportunities, and that was based on the Draghi report that we all know. And this picture here is a kind of a wake-up call. The top level items are digital, the bottom level are sustainability, and on the horizontal axis, that is the readiness level. So how ready are we? And we see that for digital, we are below the average, and for sustainability, we are higher than average. So that creates maybe opportunities to focus more on sustainability for the future, while keeping a focus on digital too, of course, because we need this for the future. If you look at R&D investments, these are the numbers if 2013, so you saw that Europe was about 50% of the US. Europe caught up, we doubled it, so now we are at the level of the US, but at the same time, the US did the same, they doubled too. And now we see that only the research in software in the US has the amount of, in Europe, the automotive, hardware, software, and health together. So this is huge. So closing that gap won't be difficult. Maybe we have to be more smarter and find other ways in order to stay competitive. You see China here. China was almost nowhere, and now China is at the level of Europe. And given the fact that the salary cost in China is lower, probably if you look at the effort, it's higher than what is indicated in this graph. And the rest of the world is also important, but much smaller than these blocks. Then if you look at science and technology clusters, this is where new companies are born, like the Silicon Valley, which is number 6 here. Europe has only 2, and European Union only 1, which is Paris. And London is position number 20. And if you look in the last column, they went down 2 positions since the year before. So this is also a bit worrisome. So we should try to create this kind of science and technology clusters to make our companies and also the SMEs stronger and to create more. This was for me a real wake up because I'm from academia. If you look at the top 10 Nature Index, this is the publications in the highest ranked journals, not just Nature, but highest ranked journals worldwide. You see that in 2016, we got 5 institutions in that list, CNRS, Max Planck, Helmholtz, and of course, Oxford and Cambridge. There were 3 from the US, not surprisingly, Harvard, Stanford, and MIT. There was the University of Tokyo and the Chinese Academy of Sciences. In 2024, which is only 8 years longer, 7 of this list are Chinese. There's only 1 American left, which is Harvard, no longer Stanford or MIT. And Max Planck raised 1 position and CNRS went down a couple of positions. So that's the situation. If we look here at 2030, there might only be 2 left, 1 from the US and 1 from Europe, and the rest might be Chinese. If this is where the basic research is being done and published, and this leads to new companies, we know where the new companies will be formed, like DeepSeek. Also in China, of course. So our recommendations, this is my last slide, is that we should invest more in large science and technology clusters, not just 1 in Paris, but I think every average-sized city in Europe with a university should try to bring university and spin-up companies together so that they can grow new companies. All the major companies, even the hyperscalers of today, were startups 20, 30 years ago. So if you don't start with startups, there are no hyperscalers in the long term. And also we promote the ARPA model of challenges that are well, more selective, I would say, and more directed to the market, and also pre-competitive procurement. And a nice example is here, the COVID vaccines. We didn't have them, but we ordered them, and the industry produced them for us. So that's also a way to speed up the system in Europe. And so these are the 2 last races, I would say. And now I give the floor back to Mark for the final conclusions.
Yeah, thank you. Just a few slides to finish. So all this information are available in the HiPEAC website. So go to the HiPEAC here. The recommendation you could download by clicking here on download vision recommendation. And if you want more detail, we have article here that will give you more insight into what we have. And we have also a small movie that you could see, but in view of time, I propose that we switch to directly to the questions.
Thank you so much. Very exciting and overwhelming information we received. So I think we could spend the whole day, in order to discuss and to ask questions about the different paradigms. Quite impressive. So what is the essence of that? First, there's a lot of things happening. So never stop thinking. You mentioned that we need more science and technology clusters to digest what is the speed of development. Secondly, it becomes more and more difficult for policymakers to understand the impact of those. So more translation, what is the technology advance in order to in the impact and the possible also policy impact. And thirdly, for me, the most important one, how could industry follow up? You mentioned the smaller companies who might find a slot or sort of a niche, to start with quickly and scale. But I'm quite afraid, how the automotive industry, a traditional industry like automotive manufacturing, could cope with it. Is you having in mind that majority of decision makers in those traditional industries are mechanical engineers, not even software engineers, and the software engineers who work in industry don't have that overview we have. So how would you think could we accelerate that uptake, or I would say the exploitation of that technology in Europe?
So I think that today it's very important to have a very high responsiveness to the market and to the new technology. When we see the top companies in the US, 15 years ago, there were oil companies and things like that. So now there are all IT companies. If you see the top company in Europe, they are still nearly the same as 15 years ago. We didn't switch a topic. So I think it's why here SMEs are really the key, because they could move fast. I think the success that everybody says about DeepSeek here and here, Well, it's not a mystery. They make publication onto their work already 1 year ago. They work with the best university. So their paper of 1 year ago was with Tsinghua University and University of Beijing. They're hiring the best students. So it's because they are very fast. They could try. They put it on the market and things like that. So I think that we should not be the old continent in terms of old, not moving fast. On the contrary, we need to go very fast. So that's need education, but also lighter process in terms of testing things. I think that we are too reluctant in Europe about failure. In US, you try, and well, if it's failed, it's failed. But on the 10 that on 9 that fail, one will really succeed. So I think that we need perhaps to have more this entrepreneurial action and to also respond fast to the market on evolution.
Alrighty, indeed, we do have some questions for from the audience, and thank you for that. I see there are some of them which were already covered, so I'm happy to see that. Some of them being on green computing, sustainable software engineering, and so on. But we do have one regarding, although maybe it might be slightly too technical, I'm going to ask it and see how it goes. It's regarding the rollout of the Internet Protocol version 6. Do you have any clue why is it taking so long?
I think this is something that we wrote in few roadmap. Again, is that we said at that time that hardware is more flexible than software. Why? Because of legacy. So we have a large base of installed system and things like that. So legacy changing thing is always a problem. And you see, you have generation of hardware using new protocol, you think that are going very fast, but all the software using it, it takes time. It need power. It need people, manpower to do it. So that is one really problem. So sometime we need to have continuity, but also sometimes you need to be able to take the jump to go to a new generation like the new IP protocol or something like that. What we promote into the NCP is a smooth evolution in the sense that it should be built on top of existing protocol so that you didn't make a jump on changing everything, but having a protocol that will be built on top of existing one so that the transition, the software could be progressive for company. But see, if you have to change all your router, all your hardware for the new internet protocol, that costs a lot for the company. So don't underestimate the cost of legacy. And here again, to update software, perhaps that artificial intelligence could help to improve productivity so that this could be accelerated.
Thank you. We'll take two more, let's say, general questions on a more rather mentality or view and vision. I see there are two questions. I'll try and make them into one. It has to do on the status quo of today. And we saw many mentions in the media as well from various companies, nations, etc., talking about sovereignty. But at the same time, we do live in a world where globalization is key and trend. So how exactly is this going to be balanced out?
Well, that's a difficult question. It's a question that is mostly covered by, I think, people and the policymakers that are worried about this. company wants to look at the bottom line. Of course, if you want to make sure that as a continent or as a country you can be sovereign and not depend on the rest of the world, in practice it's important to realize that this is not possible. Even China depends on chips and designs that are made in the US, and US depends on production capabilities in China and everything. So everything is interconnected. But of course, you want to be part of the value chain, and we have a very nice example there. We have in Europe, we have a company called ASML that make the machines that are used in fabs all over the world. So I think for Europe, becoming 100% sovereign is simply impossible. Just think about the raw materials that we do not have in Europe. But we can, of course, play an important role in the value chains. And I think for technology, ASML is a very good example. I think we got opportunities to play an important role in the value chain because our basic research is good, but we are not so good in commercializing our basic research. And so some opportunities have been gone. So our proposal is here to work on these science and technology clusters. And there are some very good examples in Europe, and I think that Saclay is a very good example near Paris, where the French government decided to bring all the technical universities together in one spot, and also the companies that should collaborate with these universities. And if you are all in the same campus, and your mission becomes to work together, then it happens, and then you see that spin-offs happen, and that all kinds of very good things come into existence. I don't think personally that Europe can compete with the current set of hyperscalers, but as we see from DeepSeek, maybe we can do something else that they left on the table and become leading in that area. And one of the areas at this moment seems to be sustainability. Apparently, neither China nor the US is interested in that topic, and we are pretty good at it. So there is a chance there to become leading. And if this technology becomes essential in the future, not only for us and for the Western world and for the developed world, but also in Africa, for instance, and South America, this could be an opportunity for us. And there are sometimes people forget there are areas where we are leading. For instance, Booking.com started in the Netherlands. I think these people know where the rest of the world takes a holiday. I mean, that's a lot of information. We could also try to build on that. And we are also a fantastic holiday destination, and that's also an industry. There's more than just IT, of course. So that's a bit my point. I think we should never give up, try new things and hope that they grow into scale-ups, unicorns, and then into global companies.
All right. Indeed, extremely good points. And maybe tied to one of our last questions, which might be tied to market and research. But in principle, the comment is advanced technologies should be more accessible to a broader audience. Besides sustainability, etc., this is an important point as well, accessibility for everyone. So then we can grow and continue to grow. Can we actually solve this? Is this solvable?
Well, there is a very big hype about artificial intelligence, but this could be also a mean to help people to have access to the digital technology, because we should not forget that there are what I call digital illiterate, even in Europe. So older people that don't want to access the web, that don't know even what is the web, and all government are all pushing things digitalized in the web. So that's difficult for them. But having some AI assistant that could talk to the people, have a more natural interaction, could really help to bridge the gap between these digitally literate people to what we are pushing here. So again, AI is not for the tech people. We should also use it for the good of the population and for societal aspect, helping people to have access to this. So it might be some idea to promote some digital assistant accessible to everybody, supported by government, countries, and things like that, that could help to bridge the gap between and to get to allow people to have more accessibility to the modern to this modern technology. Because if you have this assistant, that could be the orchestrator that could do complex things that most of the people don't know how to do it. So that could be a help. Of course, I am a techie guy, so I use the techie's response, but that is perhaps something important.
I might compliment because Fluidos was mentioned in one of the questions is one of the projects of the cluster. So we do cluster meetings, and actually what we see as an issue is definitely we have this fast technology race. And that is literally not taken up in a cluster. You know, the projects tend, you know, to continue to work on their work plan, and they have delivered results, and they're very good results. Come on, wake up, give a wake-up call. Don't wait for a CSA like HiPEAC, you know, to give a wake-up call, but echo, you know, what's happening on the market, what the people see on the market. So definitely, you know, if you have cluster meetings, take that as an opportunity to go out and say, well, look, there's something happening. We have to do something. There are gaps. We contribute in the project, and we need more agility in the projects. Final thing I want to mention, we're starting pilots on that, which is piloting technology. But one key element of the pilot is going local. You mentioned technology is difficult to understand. So I think local means that local pilots ought to have local visibility and make people technology available and understandable by local people. So, and apart from that, these pilots are open for newcomers and SMEs. So again, you know, if we have innovative SMEs who already see, you know, how to extract value of this new technology and show, you know, how can use it to bring it also on board on the pilot. So it's a task for us as a project officer, but we really, you know, make the projects, try to make the project more agile, and that's why we need HiPEAC, you know, to drive the vision and to give the wake-up call and hope, you know, we have the agility in our projects. So thanks so much for the very, very entertaining and enthusiastic presentation of the different technology trends. It's really complex, and it's our task to see, you know, where is the key element in that, where we can benefit from it, can make it, bring it to the citizens and tell, you know, what we do, and to stay on, stay on top with the race in the world with global in the global competition. Thank you so much, and wish you a good rest of the day. Thanks, Alex, for the help of the organization of the seminar, and we stay tuned for the next one. Thank you.